In this class, we're going to take a look at how you solve linear equations which have got brackets in them. So once you've done a few linear equations, once you've got going with that topic, it won't be very long before you'll start to see variations. And one of the first variations will be equations that have got brackets in them. Then you'll start to see equations that have got fractions in them. So that's the next class after this one. And you'll just start to see more and more variations. So the challenge is learning how to adapt to each of these situations and apply the rules that you already know and not think that you need a special rule for every scenario. So the scenario we'll look at today is how do I get rid of the bracket and then carry on and solve the equation as a sort of normal linear equation. So just a quick recap, a linear equation is one where the variable term, the x terms, have got a power of 1 on them, so you're not allowed an x squared or an x cubed or any higher power, and that has an implication that when we solve these equations, we're just going to get one solution. So it's quite simple actually what you do with the bracket. You just get rid of it, especially when the x is inside the bracket, which it will be. One of the x's will always be really inside the bracket. We need to kind of release it from the bracket to allow us to solve for it, because remember, eventually you want x on one side of the equation and you want all the numbers on the other. If your x is kind of stuck inside a bracket, then there's no way to really deal with that situation and get it to the point where we need it to be. So don't overcomplicate these. They're really not much beyond just being able to solve a sort of normal linear equation. We'll just start by multiplying out the brackets. Of course, if you're not sure how to expand brackets, then check out maybe a class on that first and then come back into this class, or just follow along the examples here. It's fairly straightforward, and then maybe check out a class on expanding brackets later on. But I imagine if you're already at the point of doing equations, you've probably already worked with expanding out brackets. But basically, when you expand out a bracket, you just multiply whatever's in front of the bracket to everything inside. So the 5 would multiply to the x, and it also multiplies to the 4 separately. So let's just start by doing that. So 5 times x is 5x. 5 times 4 is 20, and now this is just turned into a normal linear equation. I'm going to assume in this class you're already familiar with the basics of solving linear equations. We're dealing only in this class with particularly the cases where you've got brackets to deal with. If you're not sure how to solve a linear equation, then check out the previous class, the class that introduces you to that technique, and then come back into this one. So we're just going to move the 20 to the other side, leave the 5x on the left-hand side. That would be 30 minus 20 to give us 10. Divide both sides by 5 to give us x equals 2. So notice that really by the time that you've expanded the bracket and got to this point here, then everything after that just flows like a normal linear equation. The challenge with these is just being careful about how you expand out the bracket. Particularly when you've got scenarios like this where you've got negatives floating around, especially where you might have double negatives, just be ultra careful with those. So the 5x is not touching the bracket, so we're just going to leave the 5x where it is. We're just multiplying the minus 2 into the bracket. Minus 2 times positive 3 is negative 6. Negative 2 times negative x, that's a double negative, so that'll be plus 2x equals 1. We're going to keep these x's on this side of the equation. We can gather them together now. We've got 5x plus 2x to give us 7x. We're going to move the minus 6 to the other side. It will become a positive to give us 1 plus 6, which is positive 7. And then finally, like all linear equations, dividing both sides by the coefficient of the x to get x equals 7 divided by 7 is 1. So 1 is the solution to that equation. Not too bad. So this one up here, similar idea. We're just going to leave the left-hand side alone as we work on, first of all, expanding out the bracket. So 5 times x to give us 5x. 5 times negative 4 to give us negative 20. I'm going to gather the x's on the left again and the numbers on the right. You don't have to do that. The numbers can be here and the x's can be here, but the convention is to keep the x's, the variable term, on the left. So 7x minus 5x, I'll maybe just write this one in. So 7x minus 5x. So minus 5x because it's positive here and we're bringing it over the equal sign. Similarly, on the other side, we've got minus 20 and the positive 2 becomes a minus 2. So it's going to be like this guy here. And then 7x minus 5x gives us 2x minus 20 minus another 2, so we're going further into the negatives, is minus 22. Dividing both sides by 2, and then we get x equals negative 11. So one thing to keep an eye on with equations is that they should basically be kind of filtering down to that x value at the end. They should be getting smaller, kind of. Each line is getting smaller as you start grouping the terms together, combining the like terms. If you find that your equation somehow is getting fatter, then you're overcomplicating. You're introducing things that don't need to be there, and something's going wrong. So they should kind of taper in towards the end, like this guy here or this guy here. Okay, so let's check out this one. So the 4 is not touching the bracket, so we're just going to leave the 4. We're going to start by expanding out the bracket again. So minus 3 times x is minus 3x. Minus 3 times minus 2, that's a double negative, so that's going to be plus 6 equals x. There might be an argument in this case for taking the x term to that side, because if we take this x over here, we've got minus 3x minus another 1x, which will give us a negative number of x's. It's fine, we can do that. Sometimes in this scenario it's better to keep them positive. Let's work it both ways just out of interest. So let's start by taking the x term over here like we normally would. So in that scenario, I'll work it over here, we would have minus 3x minus x. So that positive x becomes a minus. The 4 and the 6 go to the other side. They both become negative. So minus 4 minus 6, like that. Minus 3x minus another x is minus 4x. Combining these guys, you're going to get a minus 10. If you've got one term on either side of an equation, so 2 terms in total, and they're both negatives, you can just drop the negative, if you like, and make it positive 4x and positive 10, or just divide by minus 4. So we want to get all the way to x. To do that, we would need to do minus 10 divided by minus 4. When you've got 2 negatives like that on a fraction, you can drop them anyway. So either way, you would end up with the same thing. Basically, a negative divided by a negative gives you a positive, and that one you would just need to then simplify the fraction to make it 5 over 2. With these linear equations, sometimes the answers will come out to be fractions. It's fine to leave it like that, or you could write it as 2.5 as a decimal. It might depend on the question. It might necessitate a decimal answer. For example, if it was to do with, say, money or some numerical value. Let's rework that one from this point here, but this time let's take our x terms to the other side. So just working it slightly differently. We should get the same answer. It doesn't matter how you work it. If we're keeping the numbers on this side, we're going to have 4 plus 6. On the other side, we're going to have x plus 3x. That was meant to be a 3. Like that. So notice we've ended up with just the same thing, but with different signs. These were all negatives, these are all positives. It should give us then the same answer. So we get 10, we get 4x. The beauty of doing it over here is that we don't have to worry about the negatives. We don't have to think, what do we get if we divide a negative by a negative? Is it positive or is it negative? That's why there's an argument for taking your x's to the right-hand side in scenarios where otherwise you would end up with a negative coefficient on the x. This is just uglier, it looks more confusing, there's more chance of making a mistake. The problem with this one is most students don't like the x on the right-hand side. So you look at that and you think, well, my x doesn't belong there, it's meant to be on the left. But what you can do is actually just spin the equation around to make it 4x equals 10. If 10 equals 4x, then 4x equals 10. It doesn't matter which way you do it. So you would just then divide to get 10 over 4, simplifying that to 5 over 2. So it doesn't matter if you gather things on the left or the right, that would be the same for all of these. You'll get the same answer. Sometimes, in rare occasions, there's an argument for taking the x term or the whatever the letter is, it's not always x, taking it to the right and then working it through with positive numbers, rather than just having the potential to kind of freak out and overcomplicate it and make a mistake with the negatives. So that's how you solve equations with brackets. They're just really a small extension from solving normal linear equations. The first move is always just to get rid of the bracket. It's very difficult to do anything in that form. As soon as you've got the bracket removed, it's just a normal flow of a linear equation requiring sort of 3 or 4 lines of algebra. So if you've already kind of mastered linear equations, check out some of these guys. You don't need to work too many because normally expanding the bracket is fairly simple And from that point, it's just a normal linear equation anyway. So make sure all of that I've said there makes sense to you. And then if it does, then check out a few practice questions.